Okay, we're going to be doing integration by substitution. Okay, the most difficult part of integration by substitution is, of course, making sure that you have your integral all in terms of u before you start integrating. Okay, and again, when we're doing integration by substitution, we're looking, is there a situation where we have this? Do we have a composite function where the derivative of the inside is somewhere there? Okay, so we're looking at this. I see, and this right here, that is generally our u function. And so that's what I see here. I see a function inside of a function. So I'm going to choose u to be 3x plus 5. Then when you take the derivative, you end up getting 3 dx. Okay? So I don't have 3 dx. So I'm going to divide both sides by 3 to get dx by itself. So dx is 1/3 du. This 4 right here is just a constant, so I can move that out. Okay, and that's what I'm going to do when I rewrite. So I'm going to move the 4 out here. That means I'm going to have 1 over u to the 4th times 1/3 du. Okay, so once I substitute in, this is u to the 4th, dx is 1/3 du, and now I have everything in terms of u. I'm still going to simplify a little bit because I have this other constant, so I'll move it out front as well. So I get 4/3 the integral and u to the -4 du. So I make this its negative power so I can integrate even easier. Okay? So when you take the antiderivative, you get 4/3 times, you get u, add 1, so you get -3, divide by -3, plus c. Okay? That means that this is going to be -4/9, and u is 3x plus 5 to the -3rd power plus c. And if you simplify this even further, dealing with that negative power, you'll end up getting -4/9, and then it moves to the bottom, so this is 3x plus 5 cubed plus c. And that's your answer. And like I said in my other video, once you have this antiderivative, this is the antiderivative, which means if you take the derivative, you should get back to where you started. And you can, of course, do this doing chain rule, and you will get back to where we started. All right, so again, first thing I notice about this function, I've got a function inside of a function. So my u is going to be this inside function. So this is u. So 1 plus 1 over x. Then you're going to take the derivative. Derivative of 1 is 0. The derivative of 1 over x is -1 over x squared. Okay? These are ones that 1 over x, we've seen a lot of it coming up to this point. So you should kind of know this one. If not, then you'd change it to this. You would change it to x to the -1 when you take the derivative. And then, of course, subtract 1, which will give you -2. Sorry, multiply it up front, you get this. But we've seen it so many times that we should know it. Okay? Now, it doesn't look like I have that, but again, we've talked about this before. I can rewrite this as 1 plus 1 over x cubed times 1 over x squared dx. Because dividing by x squared is the same thing as multiplying by its reciprocal, which gives me this. Okay? So, when we go to substitute, we do have to get this to be -du equals 1 over x squared dx. So, do our substitution, we get the integral, and this is u cubed times -du. So we can move that negative sign out front. So we get negative u cubed du. Take the antiderivative now, which is easy, so u to the 4th over 4, that's negative, plus c. And the last step, plugging u back in, so we get negative 1/4, 1 plus 1 over x to the 4th plus c. And that's our answer. Okay. If you haven't noticed, it's like we're doing the exact same thing over and over and over and over again. U-substitution should basically get you to the point where you have u to some power, add 1 to the power, divided by the new power. The hardest part is actually getting it into that situation. So just doing a little bit of algebra to get it to be there. All right. Here we go. So again, this one I do not have a function inside of a function. But I do know that the derivative of x squared is x. So I'm going to say this is my u. So we're going to say u is, x squared plus 1, which means du equals 2x dx. And I do have x dx, so 1/2 du equals x dx. Okay? So I'm going to rewrite. So I have the integral. Let me use a different color. The integral, and this is going to be 1 over u times 1/2 du. Now again, that 1/2 is just a constant, so we move it out front, so 1 over u du. And at this point, we have 1 over u du. You should know that that is basically going to be the natural log. So when we take the antiderivative, if you try to do the power, you would say this is u to the negative 1, and then when you do the antiderivative, you add 1, which you get 0 over 0, and you can't do that. So that should clue you in that this is one of those special ones. Not to mention, we have it in the form of, look, the derivative of u over u. And when we have it that way, that should clue you in that that's natural log. So this is 1/2. This is ln of u. Okay, now we're dealing with the definite integral. So what I am going to do here is I'm going to use my original u and change my limits. So when I plug in 2, so this is 2 squared plus 1, which is 5. And then I'm going to plug in 3, which is going to be 3 squared plus 1, which is 10. So my new limits are from 5 to 10. So when I go to evaluate this, I'm going to evaluate it from 5 to 10. Okay? So my original limits were 2 to 3. I'm going to evaluate it in terms of u. So I plug these values into this equation so that I can find my u values. So it makes my life easier. So 1/2 natural log of 10 minus 1/2 the natural log of 5. Okay? So what we can do here is we can actually put these two together by using some log properties if we want. The 1/2 can go to the power. That's the power property for logarithm. So this is the natural log of the square root of 10 minus the natural log of the square root of 5. And when you have two logs at the same base, you subtract them, you can actually do this as the square root of 10 over the square root of 5 using my log properties, like that. And if you want to do it even further, you could say that this is the natural log, and this is the square root of 2 times the square root of 5 over the square root of 5. And these divide out, which just leaves you with the natural log of the square root of 2. Okay, but that's just using some natural log identities. Okay, but notice that we're doing the same thing we've been doing this entire time. Picking u, looking for its derivative, substituting, and then integrating really easily.